Now let's talk about the multi-step method. Okay, multi-step method. So this is different as our Range-Coulter method, which is one-step method. The Range-Coulter method, basically, we only use the current step to predict the next step value. But for the multi-step, we will use several preceding steps to predict the next value. Okay. So the basic idea here is to use 2 or more preceding steps to estimate the next step value. For example, we have our general form y prime equals fxy. And we know this is an initial value problem, so y0 equals fx0. Okay. Then we can get actually the generated form for getting the next step yn plus 1 will be equals to yn plus some integral from xn to xn plus 1 fxy dx. So this is the same as before. Here we will replace, for the multi-step method, here we will replace the fxyn here with an interpolating polynomial. Approximate with the previous values. And really the order of the polynomials decide what kind of method you are using. So the order of the interpolating polynomial identify the particular method you are using. Okay. And we can draw a plot to see the difference between the one-step method, which is the Range-Coulter method, with our multi-step method. So if you have a 2D plot, which is x and y, and you have xn plus 1, you have yn, and you are trying to predict yn plus 1, right? So it's like here, you want to use the current step to predict the next step. And for Range-Coulter, basically, you have this step h for higher order Range-Coulter. So for the first order Range-Coulter, you assume the slope is constant based on this point. And as you go higher and higher order of the Range-Coulter, you basically add more points in between to estimate what is the average slope of in between these 2 points. So for Range-Coulter, we are evaluating the derivatives in between xn and xn plus 1. It's only between xn and xn plus 1. And for the higher order Range-Coulter, we basically just split the h, with a factor of alpha, then start to fill in more and more points so that we can estimate what is the slope in between. Well, for the multi-step method, we also, if there are some previous numbers available, for example, we have this one, and if we have some previous step available, we will use this multi-step so that it can be a little bit faster. and also keep the same accuracy. So we will talk about the general form, how we can generate the multi-step method, numerical method, to estimate the ODEs with initial value problem. Okay. Let's make an example. Start with the zeroth order polynomial. So what is zeroth order polynomial? That is a constant. And you assume that fxn, yn, that will be just y prime equals to fxn, yn, that is a constant. We say fn. And then yn plus 1 equals yn plus from xn to xn plus 1 is fxn yn dx. That is the general form that will be equals to yn plus xn to xn plus 1. Fxn is a constant, dx, and is basically yn plus hfn. And you can see that this is the same form as Wooler's method, right? Wooler. And the local arrow will be the order of h squared. The global arrow will be on the order of h. So that is simple. Let's try the first order polynomial, which will be a line, linear line, right? Then our fn will be equals to, our y prime equals fx n yn will be equals to fn plus fn minus 1 divided by h times x. So that is a line. And then we can get yn plus 1 equals yn plus the integral from xn to xn plus 1. And instead of a constant, we put a line there, which is fn plus fn minus 1 divided by h. X dx. And we can do this integral, which is yn plus hfn plus 2 over h squared times h over fn minus 1. So in the end, you can get yn plus h over 2, 3fn minus 1. And the minimum n number will be 1. So y2 equals y1 plus h over 2, 3f1 minus f0. And you know f0, that is basically from the initial value, fx0, y0. So you know what is f0. But what you don't know is this part is not known. This part is not known. So what you can do, it's very simple. So you can use basically any method to estimate what is your y1 and f1. So you know y1, then you will know f1, which is the fx1, y1, right? So we can use Range-Kutta method as a starter. Then we can guess what is y1, what is f1. Then we can solve y2. And then as you know y2, you can solve y3, y4. Each step, you can just estimate one step. So this part, the local arrow will be h to the third.